Okay, in Exponents 6 notes, we're going to put a little bit of all the rules or all the laws that we have already seen into place. All right, so we've already talked about the product of powers rule. It says if you're multiplying exponents or if you're multiplying powers, then you add the exponents. We've also talked about the division rule, which is the exact opposite of that. So like if you're dividing powers, you subtract the exponents. And then in the last video, we talked about the powers of power rules. So like if you have an exponent outside of the parenthesis that has the power over another power. So in this node sheet, the title of it says quotient of powers, which is like another divide set of problems, but it puts those other laws into play as well. All right. So if you remember, the quotient of powers, if you're dividing two powers, then you end up subtracting the two exponents. That's going to be the main thing behind this lesson, but you're going to have the other ones thrown in there as well. All right. Now let's go ahead and talk about E-man. Okay. I know in the past lessons I've asked you to cross this part out, but E-man is actually something that might help you out a little bit. E-man is a mnemonic, all right, that tells us what rule or what operation to do if we're at a certain law. So like if we're at the exponent to exponent law, the very next letter in E-man tells us to multiply the two exponents. Well, that's what we talked about last week. So that's like if I have x squared cubed. If I'm at this law, if I'm at this step, then the next letter in E-man says you multiply the exponents. Well, that's what we talked about last week. Okay? But it works for all the letters in E-man. So like if I come up to a problem and it looks like the multiply law of powers, like if I have x squared times x cubed, well, E-man says the very next letter after the M in E-man is the add. Well, sure enough, that's what we're supposed to do. So if I find myself at this kind of problem, then E-man says we add the two exponents. Okay? Now, the last two letters in E-man, really, we don't use a lot. You do, but you don't know that you're doing it because adding powers, like x squared plus x squared, that's just like combining like terms. That's a 1x squared, and that's a 1x squared. All right, so E-man tells us we do nothing with that exponent. That's still going to stay in x squared. We're just going to end up with 2x squareds. Okay, so E-man can help you out whenever you're looking at the laws of exponents. All right, so if we're at exponent to exponent law, E-man, the next letter, EM, says we multiply the two exponents. If we're at the multiply law of exponents, if I'm multiplying powers, then E-man says, right after the M in E-man, says that we add exponents. And if you're adding powers, that's just combining like terms. We don't do anything with the exponents. All right. So also we can use E-man because opposite of multiply would be divide. So if I'm at the divide rule, then I do the opposite of adding, which is subtract, which is what we are talking about today. If I divide powers, you subtract the exponents. So that's E-man. Might help you out, might not. All right. But E-man will keep you in order. So our examples for today, question number 1 starts off with a big old fraction. We talked about this a couple lessons ago. We already did the quotient of powers, and that's exactly what I've got going right here. Except my first two numbers are not exponents. They're just regular coefficients. So what do you have whenever you do 6 divided by 30? Be careful. Don't tell me it's 5, because remember the smaller number is on top, so you're going to end up with a fraction. Okay. And with the other ones, the powers, you have an x to the 8th divided by x to the 10th. That's really x to the 8 minus 10, because we're doing the subtract rule. Alrighty. And then for our y's, we have y to the 0 over y to the 3. You can think about this as y to the 0 minus 3, or you can just understand that that guy cancels out. Remember, anything to the 0 power simplifies down to 1. All right, so if that guy's gone, then I really just have this y to the third, and I can go ahead and put him on the bottom. Okay, if he's on the bottom over there and he's not a negative number, he can stay on the bottom. Alrighty, so whenever I work this out, this 8 minus 10 is going to end up giving me a negative 2, and I know that that is something that needs to be put down here on the bottom. So the final answer I get when I do this quotient rule, I'm going to be moving this x guy down to the bottom, so the only thing left on the top is a 1, and then down on the bottom is our 5 for the 1/5. And I'm going to bring this x guy down. I'll write him first because he's alphabetical. I moved him down because that becomes a -2 exponent. And remember, -2 negative exponents are bad kids. You put them in the basement. And if he goes down in the basement, you got to put them all in alphabetical order. So that's x squared. And then we still have our y cubed down here. All right. What happens if you have a quotient rule inside the parentheses with an exponent outside the parentheses? Well, just like PEMDAS says, we do the stuff inside the parenthesis first, and then I can do exponents. All right? So I've got to take care of the stuff inside my parenthesis first, then I can do this power to power rule, or exponent rule, exponent law. So inside the radical, I see that I have 2 over 4. Well, that's going to reduce to 1/2. And then I have an x to the 1 over x to the 10. That becomes an x to the 1 minus 10. And then I still have a y down on bottom. I don't have anything to divide that with, so let's just keep y down at the bottom. Now remember, all this stuff is inside a parenthesis with that guy outside. Alrighty? Now when I go ahead and do this quotient rule, this 1 minus 10 becomes a -9. So that's really x to the -9th power. That's a bad kid, a negative exponent. He needs to go down to the bottom. So let's go ahead and do that. This is going to end up being 1 over 2 x to the 9th y, all in parentheses, to the 3rd power. Now if you remember with this product rule, or excuse me, the power rule, if you have a parenthesis outside, or if you have an exponent outside the parenthesis, then that exponent has power over everything inside there. That means the 1 is going to be under the power of 3, the 2, the x to the 9th, and the y. So let's go ahead and put that exponent on there so I can get rid of my parentheses. Alrighty? So if I write this down, it's going to end up looking like this. 1 to the 3rd power over 2 to the 3rd power times x to the 9th to the 3rd power and y to the 3rd power. Okay, just so that you know that it expands out that way. Now once you realize that, we can go ahead and perform those exponent operations. 1 to the 3rd power is just 1. 2 to the 3rd power is 8. X to the 9th power raised to the 3rd power, we're going to end up multiplying these exponents because this is exponent to exponent rule. Remember, E-Man says that if you're at exponent to exponent rule, the next letter is multiply. So we multiply those two exponents. So if I have x to the 9 times 3, that ends up being x to the 27. And then this is y to the 3rd power. Technically it's y to the 1, so 1 times 3 would still just be the 3rd power. Alright? So if you've got stuff in your parentheses, simplify inside the parentheses until you can't anymore. Then you can work your exponent outside the parentheses. Let's go on to the other page, or the back side of that one. I've got 2 more examples. Question number 3. This one has a division problem with a exponent problem on the bottom. All right? You cannot simplify this division first and then do the exponents because the exponent, this guy, is only on the bottom. We need to go ahead and take care of him first, and then I can work my quotient rule. Okay, this is different because I only have parentheses on one side of the fraction. If this whole fraction was in parentheses, then I could work it, which what we can do on number 4. We'll do that when we get there. So I'm not going to do anything with the top just yet. We'll have a 12 x cubed y to the negative 6 over. On the bottom, though, this exponent is going to go to everything in that parentheses. So that's really going to be a 6 squared. That's going to be an x cubed squared. And that's going to be a y to the negative 2 squared. All right, once you got it looking like you want, go ahead and work those exponents out on the bottom. I'm still going to end up with a 12 x cubed y to the negative 2 on top. On the bottom, 6 squared is going to change to 36 x cubed squared. That's exponent to exponent rule, which in EMAN says we multiply. So 3 times 2 is going to make x to the 6th power. And then y to the negative 2 squared. Negative 2 times 2 is a negative 4. So that's y to the negative 4. Alrighty. Now I've cleared out my parentheses and I can perform my quotient rule. Quotient rule is our division thing. Now remember, 12 and 36 are not exponents. They're just regular old numbers. What happens when you divide 12 into 36? You get a fraction that's 1 over 3. Alright, and this x, your x's, you're going to have x to the 3rd divided by x to the 6th. Well, that's quotient rule, which says that we can do x to the 3 minus 6. Alright, and with your y's, we have y to the negative 2 minus a negative 4. Okay, be careful with your negative signs. We're going to have y to this exponent minus this exponent. So negative 2 minus a negative 4. Be careful with all that, okay? Now, go ahead and do this quotient stuff with these exponents. This 3 minus 6 is going to end up being a negative 3. Well, that's a bad exponent that needs to go down to the bottom. This minus 2 minus a negative 4, that minus a negative is going to clean up to a plus. And minus 2 plus 4 is going to end up being a positive 2. So that guy can stay up at the top. All right, so when you're ready to write your final answer, we're going to end up with 1 on top and a y squared on top over 3 on bottom. And this guy's going to move down here, and he's going to become x to the positive 3. Good deal. Okay. Keep your laws in order, and it's going to help you get your situation. All right, let's see if we can get this one done before time runs out on my video. All righty, here I've got a problem inside parentheses, so I need to continue. I need to do that before I can do my exponent outside. So 81 over 3 becomes a 27. Okay, a to the 3rd over a to the 3rd becomes an a to the 3 minus 3. B to the 10 over b to the 0. Hey, what can I do with that? I can just get rid of that guy, right? Okay, so that's really just b to the 10. That all is in parentheses, squared. All right, remember this squared has power over everything in there. Hey, by the way, what happens with this 3 minus 3? That's 0, right? And that can cancel out, so that's really gone. So all I'm going to end up with is this 27 squared. That's gone, and this b to the 10 squared. All right, 27 squared is going to end up being 729, and b to the 10 to the 2, we multiply those because that's exponent rule, and we end up with b to the 20. No negative exponents, no 0 exponents. This is going to be my answer.